Okay, so today we're going to look at future value annuities and the big difference between the problems from last time, and they're still going to be compounding, and so the formulas look very similar. In fact, you can see the formula right here, and it uses a arithmetic sum to come up with this shortened version. So we're not going to derive that, but here's kind of the analysis. In the problems that we did before, we would start off with an initial investment, an initial investment up front. It's called a lump sum up front, and we don't make any other payments the rest of the time, and then we just track that money over time, and it grows a certain amount. We don't continue to make more payments to that investment. It's just, how does that one lump sum at the beginning grow after a certain chunk of time? This one's different. An annuity, what it means is that you're going to be making regular payments. It's not just the one payment up front. You're making a payment at the beginning of every month, or at the end of every month, or at the end of every year, or at the end of every quarter, but you're making regular payments. And we're assuming that we're going to make the same payment every single period, every single month, every single year, and so on. That's what distinguishes it. So what you're going to notice here is that in our previous problems, we started off with, say, an initial lump sum. That was our initial present value, and we didn't make any payments, so the payment was zero. What you're going to find in this section is that we're starting with zero, and the payment is going to be a regular amount. And it's this amount that we invest. Again, it's cash out. We're investing it, so we're going to put a negative in front of it. But it's going to be made every month or every quarter. And that's what an annuity is. It's a more realistic way of investing, because when you get your full-time job and you're getting that, every 2-week check back, if you work for a company, then probably when that money comes out, you'll just say, hey, take out $200 each paycheck and put it into your 401k or some other investment thing. And so you'll be making regular payments, and you can actually have that taken care of via payroll deduction with your employer. But that's the big deal. I mean, that's the big change is all. And the variables that we use are the same thing. However, instead of calling it A and P, we're going to be more descriptive, and we're going to call it FV for future value. That's actually in our formula. It also appears in the TVM solver, so you'll be able to link those two. The payment is the regular payment. What you'll notice in here is that there's no present value, this one here. So the present value is always going to be zero in these problems. This means that the idea is that we're going to start with $0, and then we're going to invest a certain amount of money every month or every quarter or every year. But we start with zero, and that's what that means. So this is what you're going to put in to the TVM solver for almost all of these problems. Notice there's no present value in this formula. The I, that's the per period rate. You get that as before by taking the R value and dividing by M. And then this little n here is the number of payments. That's the M times the T as before. In the TVM solver, that's capital N. So if we rewrote this formula, it would be the payment, and then you'd have 1 plus I, which is R over M, to the MT power minus 1, and all of that is divided by R over M. So this would be kind of the expanded formula if you make these two conversions. All right, let's work through some of these problems. I'll include this handout here too. This is almost always the same, no matter whether we're working in section 3.2 or 3.3 or 3.4. N is the number of periods throughout the entire investment time. Your compounding factor times the number of years. And that's equal to N in our formulas. Remember to put in the percent as or the R value as a percent, not a decimal. Present value will be 0. Start with a 0 accumulation. Payment, be sure to put in the negative. If both the present value and the future value are positive, it's going to give you an error. And this payments per year down here and compounding per year for our problems, always going to be the same. And this is a feature of an ordinary annuity. There are applications where the payment we would select begin, like on your, if you ever get a lease on a car, they always calculate the interest up front and make you pay it up front. Pay the interest at the beginning of the period as opposed to the end. But ordinary annuities are such that you pay or receive the interest at the end of the period. All right, let's work through some problems. The first one is just getting you comfortable with the formula. So it's this formula here without the breaking down of the I in the N. So we do know that we have quarterly payments. If we just take a look at number 7 here, it says find I, the rate per period, and N, the number of periods. So what they want you to do here is to say, well, I is equal to R over M, and N is equal to M times T. So those are the two formulas, find I and N. So this formula, I think I saw a couple of errors on there. I kind of indicated them in yellow, but it looked like you divided both times or multiplied or something. So this formula here, if you solve it for, well, I guess you want it in this one here because you're looking for I. All right, so let's look at this problem here. Quarterly deposits, so M is equal to 4. Payments of $500 are made for 20 years, so T is 20. This 500 would be the payment. We're not going to use it now, but if you did, you would enter negative 500 into the TVM solver. That pays an interest rate of 8% compounded quarterly. So the I percent would be 8. All right, so after you pick out all the information from the problem, then we're just going to apply these formulas. I is equal to R, which is 0.08, divided by M, which is 4. Write it out, convert to a percent. So you have 4 quarters in the year, and every quarter you earn or pay 2%. 2% and 2% and 2% and 2% over the 4 quarters will total 8% total. And the other one is the number of periods. We're going to take the M value quarterly and multiply it by the number of years, 20 years. So that's 80. So 80 would go into the very first slot up here as the TVM solver, if you were going to do it. All right, we'll stop here with this one because they don't ask us to do anything else. They just wanted you to find the I and the N, and those two equations are exactly the same as they were in the previous section. All right, and I think there are several other problems in that section of that sort. All right, so this one says use the future value formula to find each of the indicated values. All right, so when you're showing work on tests and so on, you can either start and do the entire problem algebraically, or you can do it with the TVM solver. I think you'll find that the TVM solver is easier. But what I will ask you to do is, if you use the TVM solver, that you give me all of the inputs that you used. All right, So let's take a look at number 18. I can do any of these algebraically if you'd like, but I'm more interested in showing you how I would like you to do the problems outside of class. So write this template that has all of these inputs here. And as you're learning this for the first time, you're going to make mistakes. But some of these things are easier to put in here than others. So go to the ones that you know how to do and then try to figure out the others later. For example, they tell us that the future value is 2,500. So I'm going to put 2,500 in here. Future value will always be positive. All right, the n is 10, and the I is 0.08. Well, the problem here is that we don't know m. And without m, we can't go further on this. So normally I would use a TVM solver, but I could probably deduce what a m would be, but I won't do that. They don't give us a lot of information, but you can use the formula. And so I'm going to use the formula. And I'll use it in the same version that they gave it to you. So we take the payment, and we have 1 plus I to the n minus 1. I don't know if you can see that. Here it is here. So 2,500 equals the payment, whatever that happens to be. And then we plug in 1 plus 0.08 to the 10th power minus 1. So we need to plug in the I value. That's good, it's given to us. Plug in the n value. Good, it's given to us. Future value is given to us. Payment is not. All right, so let's solve this. We're looking for the payment. In the formula, the payment will come out as a positive number, as it should. In the TVM solver, however, it comes up negative. So I'm going to evaluate all this stuff here. I'm going to evaluate all the top first, and then I'm going to divide by the 0.08. And you might think it's tedious to write down all these decimals, but the whole display of your calculator is going to be there. So now I just have to divide both sides by this 14.4 number, and then that'll give me the payment. So I have to take 2,500 and then divide by this number, which is my last answer. So second answer. Okay, so if you make payments of 172.57 and you make 10 payments, because n is 10, you would have invested about $1,725, but it will grow to $2,500 after those 10. This is a fairly nice interest rate. And maybe I'll work one of these out after class, or if we have more time, I'll do this. But I want to get into the TVM solver problems, and so I'll hold off on doing any of these other ones. What's interesting is that these all come in the same section. These first two are easy, because it's just a matter of punching things into your calculator. This one is a little harder because you have to solve an algebraic equation. This one and this one and this one, they're all very difficult because you're solving for a different. So the algebra involved is going to be different. So I'll do one of these, maybe I'll do 20 and 21 in notes. So if you want to see how to do those algebraically, check out the notes. If we have time, we'll do it another one here. All right, let's take a look at some of these applications. The focus in here will mostly be on the applications rather than plugging numbers into formulas. So a self-employed person has a KEO retirement plan. This is the type of plan that's free of taxes until the money is withdrawn. It works a lot like an IRA, but the KEO is for those who are small business people. and they don't have any source of a pension, so they create one for themselves. If deposits, okay, so this is deposits, another word for, it's plural, so there's going to be more than one. This is like an investment. They call it a deposit. It's not really a payment because you're investing this money. So if it's a deposit of 7,500, we're going to that's going to translate into the payment of negative 7,500 because it's cash out. It's the business owns this money, and when they invest it, they could lose it all. So it's cash out, and the future value would be cash in. Are made each year. And so the M is equal to 1. Here you can see compounded annually as well. M is equal to 1. So down here at the bottom, we have payments per year and compounding periods per year, each equal to 1. There's no mention of any other compounding or payment period time frame. How much will be in the account? What they want you to do is they want you to find the future value. How much will be in the account in the future? And then here's your T is 20 years. All right, so present value is 0 in these problems. Future value is our what we're looking for. So I'm going to leave that back blank. I'm going to come back to it and do an alpha solve on that. And then you've got I%. Usually the interest rate is not too bad because it appears in the problem. And then the N. This is the number of periods, so this is not the number of years. You have to take the number of periods times the number of years. And so there's one payment per year, and there are 20 years. So in this case, the N is equal to 20. At 8%, and so as you're doing more of these, the goal is to kind of estimate what would be in the account. And at 8%, money will double about every 9 years. There's about 2 9-year periods in 20 years. So that's 2 doubles. Okay, but this is $7,500. So if you just think about how much you're investing, you're making 20 years worth of payments, and each payment is $7,500. So if you just multiply those two, this is how much you invested. It's a lot of money. But the future value is what that money grows to over those 20 years. So this is how much you invested. Let's go calculate the future value to see how much. And then we're going to calculate principal. And the other thing is the interest. And when you add those two together, you get the future value. All right, let's type things in to the TVM solver. We got 20 and 8 and 0 and negative 7,500. And that's what we're trying to calculate. And those numbers down here are ones. This is always end. So go back up to what you're trying to, this is the one we want to calculate, the future value. So it will not allow you to advance if you leave it blank. So you can't go up or down until you put something in that. So usually I just put a 0 and pass by and then come back to it. All right, so from here, you want to do alpha, the green key, and then enter. And there it is. So it's a very nice amount, $343,000. And only 150 of that was what you contributed. The rest of it is the interest. So if you take that amount of money and subtract $150,000, which is what you contributed. Very nice. If you can save $150,000 by the time you retire, you'll have $343,000 in there. It's only after 20 years. Most people work for 40 years of their life. So that's another 20 years of investing and earning interest on $343,000. All right, so what would this be, 19? All right, so all of this is interest. You earned more interest, or whoever did this investing, earned more interest over that 20-year period than what you actually invested. This is the way compound interest works. All right, I just wanted to go that because they are going to ask you to calculate the interest quite often. So it says how much will be in the account, and that's the future value. So the answer to this one is, and we're always round to the nearest penny, unless instructed to do else otherwise. What's nice about the TVM solver is that as long as you enter in the correct inputs, the calculator will give you the correct answer every time. There's not a different algebraic technique to solve a problem depending upon what they give you. If we had to do all of these with formulas, we'd have to know how to solve polynomial equations. We'd need to know how to evaluate expressions, how to solve linear equations, and how to solve log equations, or even exponential equations that use logs. That's what I meant to say. With the TVM solver, you just have to link up the variables, and you have to enter in every variable except the one you don't know, and then you calculate the one you don't know. So this is a very powerful tool. I use it still all the time, even in my life right now, to calculate projected future amounts. And you'll see in the next section to calculate if I have a certain amount at retirement, how much can I pay myself each month so that it'll last till I'm 100. Questions like that. Okay, let's take a look at the next one. Offered an annuity. Okay, so annuity, that implies regular payments. Now, all of the problems in this section will use this formula, so all will be annuities. They'll throw in a couple just to keep you honest, but a couple of problems from the earlier section. But when you see all these problems together on an exam, the first thing you're going to want to decide is this an annuity or is it a lump sum problem? Because depending upon how you answer that question, you're going to approach the problem in a quite different way. All right, so R is equal to 0.055, I%, on the other hand, 5.5. Compounded monthly, M is equal to 12, so that means the payments per year and the compounding periods per year would also be 12. What equal monthly deposit? So in this case, we're looking for the payment. It's a deposit or it's an investment, but the way we enter it into the TVM solver is it's like a payment. Should be made into this annuity in order to have $100,000 in 10 years. So T is equal to 10, and the future value is equal to 100,000. And so what should the payment be? Right. Again, I'm going to use the TVM solver to do this problem. Now, the N value is equal to M times T. Now, we know both M is 12 and T, which is 10. And so that's going to be 120. So you could type in 12 times 10 here or just equal 120. 5.5 is the interest rate. We start with nothing. We're going to make regular payments. I'm just going to put 0 and scroll by that one. In the future, we want to have 100,000, and we're going to be making monthly payments. So every number is associated with this problem except for the payment. And that's the one I want to calculate. All right, so this is 10 years. And you're going to make some payments. So if you divide this 100,000 by 10 for 10 years, that means $10,000 should be invested every year. And if you broke it down by the month, then, you know, if you divide it by 12, $10,000 divided by 12, you know, then you're talking about, you know, maybe, what, $9,000? But interest is going to be earned. And so you don't have to invest quite $9,000 each year. So it's good to think about what a reasonable answer is first, because if you don't, then you're going to get some bogus numbers and it's not going to work out for you. All right, here it is, 626.93. Don't be bothered by the negative. That just means when you're investing, you're taking cash out and putting it into an investment account. You could lose it. So in accounting, cash out is a negative, cash in is a positive. So TVM Solver tells us that this is the number we get. And so the regular payment, we translate that, 626.93, and round to the nearest penny. If we take 626.93 and multiply it by 120, we have invested 75,000, but we end up with 100,000. So we have $24,000 in interest that we've earned. Okay, there's one application, it's called a sinking fund, but as long as you know that the sinking fund is another future value annuity problem. And when, say, schools like Delta College, they have a millage this time coming up this election. And a lot of times the millage you agree to pay as a taxpayer, homeowner of this area, you agree to pay Delta College taxes twice a year. And, you know, $100, $200, something like that. Sometimes the schools say, well, we want your permission to borrow money. And we're going to borrow the money and you're going to pay it in taxes. But so that's why we get to vote on it. And a sinking fund asks the question, okay, I need this chunk of money in the future because I want to build a new athletic facility. I need $2 million. And I want to start building it in 5 years. So how much should I invest each month, each year, each quarter, so that by the time 2 years comes and I want to start building, I'll have the $1 million or $2 million or whatever it is to build the building. So it is an annuity problem. It's a slightly different context because you're not saving for your retirement. It's really some school is borrowing money and the amount that they're collecting every month will lead them to be able to pay for something in the future. But so just equate sinking fund to a future value annuity. I mean, other than that, the problems are very similar. So let's take a look at how this would be applied. Parents have set up a sinking fund in order to have $120,000 in 15 years. So maybe their child is 3 years old and they want to have $120,000 in that college fund. So when the child goes to college, they won't have to worry about, you know, where the money's coming from to pay the bills. But the amount that you want to have in the future, that's the future value. You see the number of years here. That's what we call our T. We're going to assume an annual interest rate of 0.068. If you enter it into the TVM solver, it would just be 6.8. And then because of this compounded semi-annually, this is the value of M, which is also the payments per year and the compounding per year. How much should be paid? How much should be paid? Here's the question, and how much should be paid semi-annually? This is the payment. So this is another problem where we're looking for the payment. Okay, so again, if you can pick out the information in the correct values of the correct variables, then it's just a matter of plugging the numbers in and using the TVM solver to calculate the missing amount. Future value is the 120. Payments per year, compounding periods per year, and then the interest will be paid at the end of the period. N is M times T. So the M value, because of the semi-annually, is 2. And then the T value is 15 years. So this N in the TVM solver is not the number of years in most cases. You got to multiply the number of years by the compounding period. All right, let's evaluate using the TVM solver. All right, so we have 30 as the N and 6.8. All the problems in this section will have a present value of 0. I'll just put a 0 there. For payment, I'll come back to it. And then these two are 2. Go back to the payment. Alpha solve. So the answer is $2,363.07. All right, so if you're not currently a parent and you want to have $120,000 so that your child can attend the college you would like them to attend, or the college, or just about any college, then well, you know, 120,000 isn't much if you have 4 years, right? 4 years, that's only 30,000 a year. Most students can get by on that, but if you go to you know, some schools, I think Harvard now is 60,000 a year, if you have your sights set on that. Of course, Delta College is the best deal around. You won't spend that amount of money. All right, well, let's take a look. 2363.07. We're going to make that payment 30 times. So this is how much we invested over those 15 years. And the government makes it very easy for you to invest for your children's college education. They're called 529 plans. And what's nice about them is that you can put that money in there, and when you take it out, they don't charge you taxes on anything you've earned. So you would have earned $29,000 of interest. And when you take that money out to pay for college education, they're not going to charge you any taxes on it. Okay, maybe we have time for one more. And this is a nice one for you. I said it's fairly easy to become a millionaire in your lifetime. So let's say that you get a payment every month, and every month, or a check every month from your employer, and then you want to put away a certain percentage of your money. So you agree that every month you're going to make a payment, and you're going to do it from the time you start working, let's say at about age, let's say you have your first real full-time job at age 25, and you're going to retire when you're 65. That's 40 years. So you're going to make 480 equal payments. And let's say that the interest rate is 5%. You start with nothing. And let's say you want to become a millionaire. So you're interested in your future value being $1 million. Now, since I put 12 times 40 up here, we're going to make monthly payments, then these two numbers have to be 12 as well. So the longer you invest, the more that you've accumulated turns out to be interest and not your own money. So if we calculate this payment, it's $655 a month. And if you multiply that by 12, this is how much you'd have to invest each year. And if there are 40 years, this is the total amount of money that you've invested. Congratulations. It's a nice amount of money. But look what it has grown to. $1 million. You put $314,000 away. Over 40 years, it's not that bad. It's only $8,000 a year, 600 and some each month. But over 600,000, close to $700,000 would be interest. And if you have a spouse and your spouse is saving in the same way, then you would only have to invest half of that. Maybe your spouse would invest the other half. Okay, so annuities, making regular payments, not just one up front.